So hello everyone, let us solve another lead code question, that is smallest string starting from leaf. So let us read the problem statement. So you are given the root of a binary tree where each node has a value in the range 0 to 25 which represents the letters from A to Z. And we need to return the lexicographically smallest string that starts at a leaf node and ends at the root node. So they have given this example, so let us see this first example and try to understand the problem statement. So this is the binary tree that they have given, and the output of that binary tree is DBA. So let us see how they are generating this output. So we need to start from a particular leaf node and we need to end at root node, and whatever strings that we are getting from each of the leaf node to the root node, we need to find the lexicographically smallest string. So there are 4 leaf nodes here, so we need to start from each of them and end at this root node, and amongst all these 4 strings that we are getting, we need to return the smallest lexicographically smallest string possible. So let us see that if we start from this D, then we will go to B and then we will go to A. So one string is DBA. Now if we start from E, then we will go to B and then we will go to A. So this string is EBA. If we start from D, then we will go to C and then we will go to A. So one another string is DCA and the last one is EC and A. So the last string that we get is ECA. So amongst these 4 strings, which one is the lexicographically smallest? So these two are starting from E and we already have D present, so these two can't be the smallest one. So only remaining 2 strings is DCA and DBA. So let us see among DCA and DBA. So we have DCA and we have DBA. So these 2 characters are same, so this is not the point of comparison. So amongst this C and B, which one is the smallest character? Obviously this B. So this DBA is smaller than DCA. So overall we can say that DBA is the smallest lexicographically string possible starting from a leaf node and ending at the root node. So our output in this case is DBA. So let us see how we can approach this question actually. So they have said that we need to start from leaf node and we need to end at the root node. So instead of that, we can also do one thing. We can use a like normal DFS technique, and we can start from root node and we can end at each of the leaf node. Once we reach the end of the leaf node, let's say we are starting from this root node A. So we keep track of the characters until we reach the leaf node. So first we will have A, then we will have B, then we will have this D. So we have this string ABD. But this is from root to the leaf node. We want leaf node to the root node. So what we can do is we can just reverse these characters for our simplicity. So this final string will be actually denoting from leaf to root. But actually what we did, we traversed from root to leaf. So we will approach in this way. We will start from this root node and we will end up reaching at each and every leaf node. And then whenever we reach the leaf node, we will reverse the string and compare with the smallest possible string that we have till now. If this current string that we have after reaching the leaf node is smaller than the current smallest string, then this new string generated will be the new smallest string, and this is how we'll proceed it further. So let us see what I'm saying in perspective of the code now. So we will call the DFS function, and what I have said that we'll keep on traversing and storing the characters in some string. Now we have been given that this is not actually a binary tree in the form of characters. This is for simplicity I have drawn it. Actually in place of these characters they have given value. For example, A will denote value 0, B will denote value 1, similarly Z will denote value 25. So we need to convert these numbers to characters. So we can have this number and we can convert to character with the help of character and by adding the 97 ASCII value. So first we will convert this number into corresponding character, which will represent the character from range of A to Z, and we'll keep adding it to our string. So what is happening, if we have current equal to A, then after reaching to B, our current will be AB. Then after reaching to D, our current will be ABD. So we are keep on going to the left part, and we'll keep on going to the right part until we reach the leaf node. So once we reach the leaf node, our string will be ABD. So what we will do if we reach the leaf node? So let us see now. So once we reach the leaf node, how we can say a particular leaf node is a particular node is a leaf node? If it doesn't have a right child and it doesn't have a left child, that means the particular node is the leaf node. So what we have seen now previously, that once we reach the leaf node, we need to reverse this string, because this ABD string is from root to leaf, but what we want leaf to root. So whatever string we have generated from root to leaf, we just need to reverse this string, and that will denote the leaf to root characters or the leaf to root string. So we will just simply reverse this string. So once we reach the leaf node, we will reverse our current string and we will compare it with our current minimum answer or the current minimum string. If this current string is minimum amongst all the possible values of string, then our new answer will be the current, or the new smallest string will be current. Otherwise our answer would remain as it is, and we will keep on doing until we traverse the entire binary tree. So this was about the DFS code, how we will traverse and all that. So let us see in the code now how we actually write up in the code editor. So let us see the code now. So first we will declare a global string called answer, which will denote the smallest possible string, and we will do a DFS which will contain the root and the current string. Now our current string will obviously start from an empty string, and whatever smallest possible string we are getting after traversing the entire binary tree, we will return that answer. So let us write the DFS code now. So we have given the parameters as root and current. So what we will write the base case first. So if our node equal to null, that means we need to return. Otherwise, what we have seen previously, we will keep on adding the characters to our current string until we reach the leaf node. So we'll keep on adding the characters to our current string until we reach the leaf node. So how we will do it? We will add node value, and we need to convert it into alphabet. So we will write this kind of code to convert the numerical value into corresponding characters, and we need to do it until we reach the leaf node. And we'll pass the parameters as current will remain as it is. Now once we reach the leaf node, how will we see if a particular node is a leaf node? So if nodes left is equal to null, as well as node right is also null, that means it is a leaf node. So what we need to do, we need to first reverse the current string. So we will reverse that, because the current string will contain the string from root to leaf, but we want leaf to root, so that's why we need to reverse it. Now we will compare it with our answer, and this will store the minimum possible answer till now. But this code is actually not correct, because what we have seen that we have denoted the string as empty, denoted the our initial answer to be empty string. So what if it is the first time we are comparing? Then obviously this will be the minimum because it doesn't have any characters. So we need to write additional condition that if it is the first time that we are comparing this string, we need to put answer equal to the current string, and else we will compare it with the current answer or the current smallest possible string. So let us see what we are doing again. So we have initialized the current string, which will keep track of the root to leaf strings, and then we are traversing with the help of DFS. So this is the base case. We'll keep on adding the characters in our current string until we reach the leaf node. So we will do with the help of by going to the left and going to the right. So sorry, we need to write here DFS, and we are keep on going to the left and we keep going to the right until we reach the leaf node. Now once we reach the leaf node, we first reverse the current string, because the current string contains string from root to leaf, and we want from leaf to root. So we will reverse it and we'll compare it with our current smallest possible answer, which is this ANS. Now if it is the first time that we are comparing it with the answer, we don't have to actually compare it. We can just put the current string as the smallest possible string. Otherwise we need to compare with the smallest possible string till now. So this was it about the code. Let us try to submit it, if this works fine on sample test case or not. So it is giving us the error string. Oh, so we have written the spelling wrong. Let us submit. So yeah, it works fine on sample test case. Let us try to submit it, if it gets accepted or not. So our code worked fine. Hope you learned from this video. Thank you.